Okay, so this is another video in circle theorem proofs using GeoGebra. And what we're going to look at now is the opposite angles in a cyclic quadrilateral. And a cyclic just means to do with a circle, basically. So a quadrilateral is a four-sided shape of any kind. And what we're saying is that the opposite angles add up to 180 always, only if the quadrilateral is in a circle. A quadrilateral in general, we know is the angles always add up to 360, and so that will still hold. If these two add up to 180, and if these two add up to 180, then that should still hold. Now, if you go to my simulation, which I've shared, which will have all the circle theorems on them eventually, you can play around with this. But when you move this around, you'll see that that this angle here, let's say that's right. It's probably better if I move this angle around. I move this one around, then these two angles change such that they will always add up to 180. So you can get a calculator out and try that out for yourself. But what I'm going to do is try to prove why that is the case. So I'm going to I'm going to use a theorem which I've already proven from earlier on, which is that this angle is always equal to double of that angle. So I will just demonstrate that by drawing an angle on it, which is, I'm looking for angle, here it is, angle. Okay, that and that. That's getting better. I'm getting better at that. And this line and this line. Okay, so 123.1 is roughly, it should be exactly 61.6, double of 61.6, but there might be some rounding errors. So anyway, but it is double that. It's just that we're seeing the answer to the to one decimal place. Anyway, so we're going to use that rule that I've just said there in this situation. The way that I'm going to do that is I'm going to get a segment. I'm going to draw it to the middle point, from the middle point to the edge, and another one to that one there. Now, this would mean that the angle here, actually what I'm going to do is I'm just going to hide some of these angles which I've identified using the move tool. Oops, let's do that. Can I undo? Oh, now I've undone two of them. Okay, so just the angle. Hopefully that's just the angle. Oh, for God's sake. That's undone two again. It's quite fiddly. No, that's it. You can see what you've highlighted. You can see how it changes colour. I'm learning this as I'm going as well. So click. Yeah, I can see it's highlighted the angle. Delete. Right, cool. So let's choose a pen down here. And I wonder if I can, I don't know, white or draw, change colour using the bar. Okay, I don't know what that bar is. Never mind. I'll look later. So we've got, let's identify this angle as A, and using that semicircular rule, that would mean that this angle here would be 2A. If we do the same with the other angle, let's call this one B. Using the semicircular rule, this would be 2B. So if you're unfamiliar with that rule, just go back to that video or play around with the thing on the simulator to see what I mean. But we can see now, because the circle, these two are in the center, that 2B plus 2A would be equal to 360. And by dividing both sides by 2, we would see that B plus A is equal to 180, which is what we were trying to prove. So that one's nice and quick, but it only makes sense once you understand the previous rule. In fact, you don't need to understand how the previous rule is proven, just how to apply it. Okay, so I'll stop that video there.